Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Nurhani binti Indra and my metric number is H201A3070. Now I want to present and my part is data management. So there are three types of tables can be used to describe the data. Firstly, frequency distribution, and secondly, relative frequency data, and lastly, cumulative frequency data. So our group decided to choose firstly frequency distribution and secondly relative frequency data to use to describe the data. So frequency distribution divide by 2, which is firstly ungrouped data and secondly it is a group data. Ungrouped data for a frequency distribution produced whenever observations are sorted into classes of single values, while group data, a frequency distribution produced whenever observations are sorted classes of more than one value. And now I want to describe about how to calculate the frequency data. Step 1, we need to decide on the number of classes. Step 2, determine the class interval or width, which is class with it equal maximum entry minus minimum entry and divide by number of classes. And step 3, the individual class limits. And step 4, make a tally mark for each data entry in these appropriate classes. And lastly, for the step 5 is the number of tally mark for each data entry in the appropriate classes. And for the relative frequency distribution is to find the relative frequency of a class by divide the frequency f by the sample size n, which is relative frequency equal class frequency divided by sample size.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhayani binti Abdul Razak. My metric number is H201A2516. So I will continue for the part of graphical methods. There are two different graphs which are frequency polygon and ogive graph. For the first graph, that is frequency polygon requires two data, which is data from the frequency for the vertical line and midpoint data for the horizontal line. For the first class, the midpoint is 8.5, second class 26.5, third class 44.5, fourth class 62.5, fifth class 80.5, sixth class 98.5, seventh class 116.5, and the midpoint for the last class is 134.5. Data for frequency is 0, 10, 4, 13, 10, 7, 6, and 0. The line for this graph must start from 0 and end with a value of 0. For the second graph is an ogive graph. The graph it must have two data, namely upper class boundary data and cumulative frequency data. Upper class boundaries, the value for the first class is 17.5, second class is 35.5, third class is 53.5, fourth class is 71.5, fifth class is 89.5, sixth class is 107.5, and 125.5 for the last class. For the frequency data, it starts from 0, 10, 4, 13, 10, 7, and finally is 6. For the ogive graph, the beginning only needs to start from 0 frequency. Thank you.
Thank you for Hayani. Next. My name is Nurul Nabila binti Hamzah. My metric number H21A2587. Are you guys ready to make use of central register interpretation? Me, media and moods. Okay, for the first part is measure of central register interpretations. Mean. The mean is the average. The way to get mean is frequency multiplied by the midpoint for each and add by the total frequency multiplied by the midpoint for each class, then divided by total frequency. For example, in table, so the mean label force by 8 group A wilayah Persekutuan Kuala Lumpur was entrepreneur 53 years old. Median. The way to get the median is by the sum frequency divided by 2, then look at the cumulative frequency where the number is and take the class and calculate it together with the lower class, with the class size. So the median for the labor force by the 8 group wilayah Persekutuan Kuala Lumpur was 68.08. Mood. The way to get the mood is the class with the highest frequency, know with the class and so on. For example, the highest labor force by 8 group in wilayah Persekutuan Kuala Lumpur is 112.5. For the next part is mutual variation interpretation, range. The way to get range is the higher class minus with the lower class. Therefore, the range of labor force by 8 group wilayah Persekutuan Kuala Lumpur is 1982 until 2019 is 106 years. Next, variance and standard deviation. How to get variance and standard deviation by calculating frequency, midpoint, and others. For example, the sample variance is about 43,565, and the sample standard deviation is about 208. 0.18. Next is mutual position interpretation. Mutual position determine the position of a single value in relation to other value in a sample or population data set. 3. Mutual position. Qualities dislike percentage. Next is quartile. Quartile 1 is equal 12.5. Class interval 18 until 35. Quartile 3 is equal 37.5. Class interval 72 until 89. How to get the interquartile range is quartile 1 for 2 minus quartile 3 and 92.63. Range 14.63. Lastly, the shape of distribution. Mean 69.4, median 68.08, mood 120.5. This is no symmetry, a distribution of which there is no such mirror imaging. Therefore, it is skewed to the right. I will pass presentation to the next presentant.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Marjana binti Sharizal. My metric number H2182662. Today, in this slide, I would present for part B is about find one set of data that have one independent variable and one dependent variable. Our group has taken data from the internet, which is by the Economy Freedom Index 2018. The meaning of independent variable is a variable that stands alone and is not changed by the other variable you are trying to measure. And for dependent variable is something that depends on other factors. As you can see, the data show relationship between judicial effectiveness and government integrity. So the judicial effectiveness represent dependent variable, which is X, and government integrity represent independent variable, which is Y. And the sample size, or N, is 32 samples.
Alright, so we move to the next part. Hi, my name is Alia Farzana binti Ahmad Radi. My metric number is H21A1992, and in this video, I'm going to explain to all of you about the Pearson's product correlation coefficient. So, if you can see in this slide, we used to insert some of the data to the formula. So, let's check it out. So, we use this formula to make a compute. R is Pearson's correlation coefficient, equal to n, number of observation, multiply the sum xy equal to the sum x, multiply the sum y, divide by square root, and multiply x squared equal to x close the bracket squared and multiply y square equal to y close the bracket square. So if we insert using of the data, it will be r equal to 32 multiply 103823.3 equal to 1759.2 equal to 1621.1 divide by square root 32 multiply 108465.6 equal to 1759.2 close the bracket square 32 multiply 1030.72.2 equal to 1621.1 square. So the answer is 0.937. R square equal to 0.937 square equal to 0.878. As we conclude, the correlation between the judicial effectiveness and government integrity is 0.937 or 1, means there are very strong positive correlation between the variable, which is x and y.
My name is Nur Mashita binti Muhammad Fazli and my metric number is H2182982. For part B, I will present about develop estimate regression equation, then interpret the regression equation. For the formula for B0 is in bracket total xy in bracket total x squared minus in bracket total x in bracket total xy per n in bracket total x squared minus in bracket total x squared. From the data that we collected, B0 in bracket 1621.17 in bracket 103071.87 minus 1759.2 in bracket 104002.67 per 32 in bracket 108092.44 minus 1759.2. So the answer for B0 is negative 456.5. Next is formula for B1 is n in bracket total xy minus in bracket total x in bracket total y per n in bracket x squared minus in bracket total x squared. The data that we collect, B1 equal 32 in bracket 104002.67 minus in bracket 1759.2 in bracket 1621.17 per 32 in bracket 108092.44 minus in bracket 1759.2. So the answer for B1 is 1.31. Y head is negative 456.5 plus 131x. For solution, so B1 equal 1.31. For every one judicial effectiveness measure, the government integrity will increase 1.31 per country. Constant B0 equal negative 456.5. When the number of judicial effectiveness is 0, the government integrity is negative 456.5 per country.